Hi friends, welcome back. Now I am going to tell you about the inductive effect in organic compounds. Here we know that how the polarization that happens due to the electron presence of the electron withdrawing or electron donating groups in adjacent atoms or in the functional groups. So let me take the compound here. For example, the compound is, if it is very big, for example, whatever any length it can be. So as if you think this is halogen, what happens? As I said here, the minus halogens, what happened? It is minus effect. Minus effect means it pulls the electron. This is a pulling electron. These are pulling groups, pulling the electrons. Okay. So because that, what happens? It is influenced. The deficiency is more than the second one, then this one, third one, then the fourth one. So that means, it is facing what? The least. So like this, the electron pulling capacity is observed. Whereas in the case of the other groups like CH2, maybe like oxygen, maybe carboxylate group, or oxygen, let me keep here, maybe CHO, whatever it may be. So what will happen? It will donate the electron, or it is also, we call this as what? Pushing the electrons. Pushing electrons. So because of that, in the carbon chain, the electron density increases. So we call it as a permanent effect. So it's also, we call this as a electromagnetic effect, because it is okay. Before this is what happens. So it will feel the more electronegative, it will feel still more, and it will feel the still more. So it will influence. It is influenced by the electrons more than the next accumulation or density. As they move from the right hand circular, the electron density decreases. Now here, what are the major criteria that is observed in inductive effect? We usually see the compound only in the CC bonds, or the carbon-carbon. This is most of the hydrocarbons. Next, as the effect is increased on this, it is observed in where the sigma bond. It's observed because electron migration only through what? The partial polarization happens only through the sigma bonds, or in the single bonded compounds. Next, here now let us discuss some of the compounds which show the inductive effect. See, for example, if you compare CH3, CH2, let me take any halogens, okay, chloride, and here let me write the nitro and CH2, C. Now, which is more acidic in nature? That means here we know that it is what? The electron pulling. It's also electron pulling. So because of that, what happens? Here the chloride cannot detach from the molecule easily, but here the chloride can detach easily. So it can show what? The carbocation easily, because the alkyl is the electron donating group. Hence, when the alkyl group donates electron to the electronegative, we call the chloride as minus inductive effect, and we say that it is what? Plus I effect. Positive inductive effect means the deficiency of electron or donation of the electrons from the alkyl groups into chloride. Here the chloride takes up the electron from the alkyl group, so hence it becomes electron rich, hence it is negative. The shortage of electrons is seen in the alkyl group, hence it is a positive ion. So here also what? The detach is very less here, so we cannot say the chloride can detach easily. But for example, if I take any acid, for example CH3, CH2, COOH, and I'll take here the chloride CCl3, CH2, COOH. So which is more acidic? Here the more acidic is the second one. The reason is because here chloride is the electronegative, that will pull the electron towards itself. Because of that, the electron density from the carboxylate that will move from the carboxylate towards the alkyl group. Because of that, hydrogen can detach easily like this. So hence it is more acidic. Now if you see the group, the last, that is, for example, here if I take the group phenol, and let me take CH3 and OH and NO2. So which is the more acidic in nature? Obviously the second, because nitro pulls the electron, as well as the more the electron pulling character. Because of that, electron density reduces at the hydroxy group. Because of that, hydrogen can detach easily. So it's a more even if bond breaks, then the electron will lay on the oxygen atom. Here what happens? The methyl is electron donating, so because of that, the electron density increases here. So because of that, it is less acidic than the other compound. Even if you see the basic character, for example NH2 and here if I take any compound, the CH3 and NO2 here, which is a more basic character, so it is more basic than, because the CH3 is electron donating, the nitro is electron pull. Hope you have understood how the inductive effect plays an important role in determining the acidic, basic and the reactivity of the molecule in any reaction. Hope you understood the concept. Thanks for watching.